Okay, so we have a real world problem using vectors. So an aeroplane. An aeroplane is flying with an airspeed of 310 knots on a heading of 050 degrees. If a 78 knot wind is blowing from a true heading of 125 degrees, determine the speed and direction of the plane relative to the ground. So we need to draw this diagram. So our north line, this is in relation to the ground. So I'm just going to write ground. And we know that we have a bearing of 050. So we measure clockwise. So if we measure clockwise, this is going to be 50 degrees. And we can draw ourselves our vector. So this is our vector, which is 310 knots. So we're also told we have a 78 knot wind. So our wind is going to be coming towards our plane, and this is going to be forming another angle, which we're told is going to be 125 degrees. So that's combined. So we need to find this angle here. So this is going to be the difference between 125 and 50, which is 75. And knowing that we have alternate angles, we can also draw our angle here, and this is going to be 75. So I'm just going to redo my diagram. So this is my 310 knots. So this, I'm going to use this here. Let's draw that again. So this here, this can be our 78 knots. This is my angle, 75. So we write that in, 75. And we're going to draw another vector, and this is for our speed. So this is going to be g. So this is for our ground velocity, and we need to find this angle here, and in relation to our ground, if we were to draw our line back in here, our ground, this angle is going to be, we'll call theta. So theta plus x is equal to 50 degrees. So we're going to need to find x to work out theta. So the first thing we need to do is find our speed. So we're looking at this vector here. So we're forming a triangle. So we're going to call this A, B, and C. And little c, little b, little a. And this is our 78, 310. And we don't know this one. This is our angle A, which we'll call x for the moment, and we know this is 75 degrees. So we need to use the law of cosines. So the law of cosines to find the missing side. So we want to find our ground velocity. So we can do this with c squared is a squared plus b squared minus 2ab cosine of 75 degrees. So if we substitute in the values that we know, so c squared, we know a squared is 78 squared, plus b squared is going to be 310 squared, minus 2 times 78 times 310 multiplied by cosine of 75. So if we work that out, so c squared is equal to 89667.51098. And if we take the square root of that, we will have 299.44 or 45 knots. So this is our ground velocity. So let's relabel this as, so our ground velocity is 299.4 knots, or 45. And then we need now to find the angle. So we're going back, we need to find this angle here. So we can use the law of sines. So we know that this is angle A, so the sine of A over little a, which is 78, so sine of A over 78. And we're going to use the sine of C, which is 75 over little c. So this is sine of 75 over, and we found C. So we said this was 299.45. And we just need to rearrange this. So sine of A is 78 multiplied by sine 75 divided by 299.45. Because we're looking for the angle, we're going to take the inverse sine. So A is sine to the minus 1. And if we put this into our calculator, 78 sine 75 over 299.45, our angle, which I'm just going to relabel as X because that's what we called it, this is going to be 14.6 degrees. Now if you go back to our diagram, so X is 14.6 and we need to know theta. So X is 14.6. We know that X plus theta is 50 degrees. So theta will be 50 minus 14.6, which is 35.4 degrees. And we can take the bearing of 3,5. So our final answer is the aeroplane's speed is 299.45 knots, and it's at a bearing of 0.35 degrees in relation to the ground.